Hello, welcome to Astronautics for Exploit. This is Dr. Ayashola Ogundele. Mars terraforming, an innovative strategy to make Mars Earth-like. The focus points of my presentation are as follows. Mars terraforming, advantages of Mars terraforming, the motivation for Mars terraforming, and challenges and limitations of Mars terraforming. The concept of transforming Mars into a habitable planet, which was once a science fiction idea, is gradually becoming a reality. Sir Arthur Clarke, one of the world's 20th century foremost writers of science fiction, in 1951 published his book titled Sons of Mars, and the book revolved around terraforming the Mars. In The Sons of Mars, Sir Arthur Clarke describes settlement of women on the Mars and setting up of research base for various scientific exploration purposes. It stated that man terraformed the Mars by eating it up, converted Mars' moon, Phobos, into a second sun, and grew plants, which helped to break down the material sands and then released oxygen. Mars terraforming, the process of transforming and altering the Mars' hostile environment to be Earth-like, involves changing the Mars atmosphere, ecology, temperature, topology, composition, and a host of other characteristics into a form suitable for women to live and work. To effectively transform the Mars, the following changes have to be effected. The Mars atmospheric pressure and temperature must be increased. A means of having available water must be provided. Changes must be made to the chemical composition of the Mars atmosphere, and the high level of ultraviolet radiation on the Mars must be reduced to a level that is comfortable and non-detrimental to humans. One of the reasons and justifications for exploring and choosing Mars over other potential terraforming targets include the presence of water and the geological history that suggests it once harbored a dense atmosphere similar to Earth's. Mars terraforming. Mars terraforming, a hypothetical procedure to transform Mars from a hostile planet to an accommodating terrestrial planet, is an idea aimed at sustainably host humans and other life forms. The Mars terraforming strategy involves modification of the Mars' extant climate, atmosphere, and surface through a variety of resource-intensive initiatives and the installation of a novel ecological system or systems. The picture here shows artist's concept of the process of terraforming Mars. There are various proposals for terraforming Mars. Currently, several space agencies and private space companies are examining different Mars terraforming ideas. For example, NASA is working on a solar cell propulsion system, which will use large reflective mirrors to harness the sun's radiation to propel spacecraft through space. Mars Ice Home, designed for a Mars base, is shown in this picture. There are various advantages of Mars terraforming, and some of them are highlighted below. Scientists are endeared to terraforming Mars because of it being at the outer edge of the habitable zone, a region of the solar system where liquid water on the surface may be supported if concentrated greenhouse gases could increase the atmospheric pressure. Abundant liquid water is another advantage of Mars terraforming. There are strong indications that Mars once had an atmosphere as thick as Earth's during an earlier stage in its development, and that its pressure supported abundant liquid water at the surface. This picture shows illustration of plants growing in a hypothetical Mars base. Another advantage is that Mars is at the habitable zone. Although water appears to have once been present on the Martian surface, ground ice currently exists from mid-latitudes to the poles. Another advantage is that the Mars soil and atmosphere contain many of the main elements crucial to life, including sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon. An hypothetical terraformed Mars is shown in this picture. Findings show that large amounts of water ice exist below the Martian surface, as well as on the surface at the poles, where it is mixed with dry ice, frozen carbon dioxide. Significant amounts of water are located at the south pole of Mars, which, if melted, will correspond to a planet-wide ocean, which is about 5 to 11 meters deep. Most of the oxygen in the Martian atmosphere is present as carbon dioxide. The main atmospheric component molecular oxygen only exists in trace amounts. This picture shows illustration of a terraformed Mars so as to make it more habitable for humans. The motivation for Mars terraforming. Future population growth and increase in demand for resources by the humans are necessitating the need to have alternative sources of resources. Also, the increasing interest in human colonization of bodies other than Earth, such as Mars, the Moon, and other objects, is making humans to buy in the idea of Mars terraforming. Space colonization will facilitate harvesting the solar system energy and material resources. Artist's impression of the terraformed Mars from its current state to a livable world is shown in this picture. Mars, the most Earth-like of all the other planets in the solar system, is thought to have a more Earth-like environment early in its geological history, with a thicker atmosphere and abundant water that was lost over the course of hundreds of millions of years through atmospheric escape. Given the foundations of similarity and proximity, Mars will make one of the most plausible terraforming targets in the solar system. Artist's concept of a living Mars is shown in this picture. Challenges and limitations of Mars terraforming. The Martian environment presents several terraforming challenges, and the extent of terraforming may be limited by certain key environmental factors. Mars differs from Earth in several ways, and this necessitates the need to transform the Mars to be Earth-like. Space reflectors, which is also known as space mirrors, a form of solar radiation management, are sunsheets which position in space to reduce the amount of solar energy reaching the Earth, and is shown in this picture. Various challenges and limitations of Mars terraforming. The area of Mars terraforming seeks to address are to reduce light levels, about 60% of Earth, low surface gravity, 38% of Earth, unbreathable atmosphere, atmospheric pressure, about 1% of Earth, ionizing solar and cosmic radiation at the surface, average temperature minus 63 degrees Celsius compared to Earth average of 14 degrees Celsius, molecular instability, global dust storms and toxic swirl, no natural food source, and no global magnetic field to shield against the solar wind. The picture here shows terraformed Mars. Space weather is another challenge of Mars terraforming. Mars doesn't have an intrinsic global magnetic field, but the solar wind directly interacts with the atmosphere of Mars, leading to the formation of a magnetosphere from magnetic field tubes. This poses challenges for mitigating solar radiation and retaining an atmosphere. The picture here shows illustration of various sources of carbon dioxide on Mars and their estimated contribution to Martian atmospheric pressure. The lack of a magnetic field, its relatively small mass, and its atmospheric photochemistry all are thought to have contributed to the evaporation and loss of the Mars surface liquid water over time. Solar wind-induced ejection of Martian atmospheric atoms has been detected by Mars orbiting probes, indicating that the solar wind has stripped the Martian atmosphere over time. NASA's Martian in orbit, another artistic rendition of planet Mars, is shown in this picture. Low gravity and pressure. The surface gravity on Mars is 38% of that on Earth. It is not known if this is enough to prevent the health problems associated with weightlessness. Mars' carbon dioxide atmosphere has about 1% the pressure of the Earth's at sea level. It is estimated that there is sufficient carbon dioxide ice in the regolith and the South Polar Cap to form a 30 to 60 kilopascals atmosphere if it is released by planetary warming. Project Nomad, a concept for terraforming Mars using mobile factory skyscrapers, is shown in this picture. Breathing on Mars is another challenge of Mars terraforming. Without a pressure chute for life support, no amount of breathable oxygen delivered by any means will sustain oxygen-breathing life for more than a few minutes on the Mars. If Mars atmospheric pressure could rise above 19 kilopascal, then a pressure chute would not be required. Artist's concept of a terraformed Mars and an unhinged cylinder is shown in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to Mars Terraforming, an innovative strategy to make Mars Earth-like, presented by Dr. Anyashola Ogunele, Astronautics for Exploits, with focus points: Mars Terraforming, advantages of Mars Terraforming, the motivation for Mars Terraforming, and challenges and limitations of Mars Terraforming. Thank you.